Race conditions are one of the hardest bugs to analyze, reproduce and correct. They occur when multiple threads write to the same variables. Shared reading is no problem. So having written as much as possible in a pure way without mutation helps a lot in those concurrency situations. But one great benefit of functional programming when regarding multithreading is the fact that parallelism becomes a lot easier. And in many cases there are tailor-made functions available for this, so you do not have to write much multi-threaded code on your own. You simply express your algorithm functionally, and this can immediately scale to multiple CPUs. One famous example for this is the map-reduce pattern. Say you are making a fresh fruit salad. In the first step you have to prepare the ingredients one by one, like peel an orange, cut an apple and so on. All this can be done in parallel by multiple people. This is the map part. Now everything has to be mixed together. This is the reduce part. Transform is easy to run on multiple CPUs in parallel. It scales up to as many CPUs as there are objects in the list. Functional Plus provides transform parallelly that does all this internally and can be used from the outside like the usual transform. We also have reduce parallelly. But this one is a bit more tricky internally. In many cases it works in a tree-like fashion. But it could do it in any unspecified order. This means the data type and the binary function used for reduce have to fulfill some properties. Can you guess what they are? We know the order of the elements should not matter, so the function is commutative. Also, the order of the executed reduction should be irrelevant, so the function needs to be associative. And how do we call a structure containing a data type and an operation like this? If you were thinking, hey, I remember, it's a commutative semigroup, you are absolutely right. But our reduce function has one potential problem. It is not a total function. It cannot return anything if the provided list is empty and will crash. This is not good. Can we make it total? We need to give it an additional parameter, one that is a neutral element. If the list is empty, it will be returned. Otherwise, it will be reduced together with the other values. And how do we call a semigroup that also has a neutral element? Yes, it's a monoid. So in order to have reduce parallelly work correctly, you have to make sure that what you provide is a commutative monoid. MapReduce or TransformReduce is simply both operations we just discussed in one function. So let's say you are writing a cool mobile app that calculates the average face of all the faces found on images in the photo gallery. You come up with this iterative version. But it takes very long, and only one of the many CPU cores in your smartphone is doing all the work. The others wait in the background. Here is an exercise for you. Express the loop of the iterative version above as a call to transform reduce parallelly. The following types are given. When done with exercise 1, have a look at the documentation for std async and think about cases in your old projects where you could have used it to make your code easier to maintain.